Hi Math 20-1, this is your review for trigonometry. I'm going to go through it as quickly as I possibly can, but try to cover all of these points here. So these achievement indicators are basically what I use to write the trig questions, especially in the multiple choice, because I'm wanting to make sure that you're meeting at least one or more, if not all, of the achievement indicators for each of your curricular outcomes. So I kind of took that document and my list of key skills for trig came down to about 5 things. Basically, sketching the angles in standard position and determining the quadrant and reference angle. Using Pythagorean theorem to determine the components x, y, and r given a point P that is a xy coordinate. State the ratios of cosine, sine, and tan theta as exact values. Determine the sign of a trig ratio, typically using the cast rule, and then solve for values of theta given an exact value of a trig ratio. And then lastly, use the sine and cosine law. And so this should actually be S-I-N-E, the sine law and the cosine law, to solve problems. And that does include the ambiguous case when we get to the sine law. So we will check for that when we get to that question. Okay. Let's start off easy with some definitions, some fill in the blanks here. So it says a rotation angle is formed by rotating an initial arm through an angle theta about a fixed point, a vertex, beginning at a positive x-axis. Now that has a lot of terminology, and I'm going to draw you a quick picture here. Basically, rotating an initial arm means I typically take like a line, and I would start at the x-axis and I would rotate it from the vertex. Now the vertex in this point is the origin, that's 0, 0. And then that angle that we rotate through, that is what we give that name, the rotation angle. We typically call it theta. Now in this picture, if I start at the x-axis and I measure positively or counterclockwise, then I land on this terminal arm. Alternatively, I could have started at the x-axis and I could have measured negatively, and I could have also ended at this terminal arm, but that negative angle that I measure is going to be through that clockwise rotation. So positive is counterclockwise, negative is clockwise, kind of opposite to how you would think about it in terms of a clock. A reference angle is the acute angle between 0 and 90 degrees formed between the terminal arm and the rotation angle, and the key is it is always measured from the x-axis. So it doesn't matter whether I measured this angle positively, negatively. If it's greater than 360, less than 360, I go find that angle to the x-axis, the horizontal axis, and I've got my reference angle. So in example A, we're going to sketch the rotation angle in standard position and state the reference angle. So the rotation angle, 130 degrees. Here's my quadrants. Each quadrant represents 90 degrees. We can label that if we want. So 0, I rotate through a 90-degree angle. Another 90 makes 180. And the third, between the third and the fourth quadrant would be 270. And so when I see 130, I'm thinking, okay, 130 is about 40 degrees past 90, 50 degrees from 180. I'll draw my terminal arm right here. My arrow, label it theta. Theta is 130 degrees. And then the reference angle is this angle right here. And so if this is 130, I would say the reference angle is 180, subtract off that 130, or 50 degrees. So you can say I'm 50 degrees away from 180 or 50 degrees away from that x-axis. Okay. The next one, for the rotation angle of 350, we have to do a sketch. 350 is quite close to 360, so in drawing this, I know it's going to be about or close to 1 full rotation, but I'm going to draw you the 4 axes again. When I rotate through, I'd rotate through 90, 180, 270, and I would get back to 360, but I don't need quite 360. I need 350 degrees. I could call it theta. 350. Because 0 degrees and 360 degrees are what we call coterminal, so they have the same terminal arm. Okay, what's the angle right here? Well, if I'm at 350 degrees, I am 10 degrees away from 360, or 10 degrees away from the x-axis. Okay. In example B, determine all of the angles between 0 and 360 that have a reference angle of 65. Okay, quadrants first, draw a picture. A reference angle of 65 means that I have to be 65 degrees away from each axis. So, or the x-axis. So I'm going to go 65 degrees away here. That could be a reference angle. So could over here in quadrant 2, I could have a 65 degree reference angle. I could have a 65 degree reference angle in quadrant 3, and though my picture is not drawn to scale, that does not look like 65 degrees, it looks more like 30. That's okay, it's just a picture. And then 65 degree reference angle in quadrant 4. So when we say determine all the angles, there should be 4 angles, and I'm just gonna put them in their quadrants. In quadrant 1, I rotate through 65 degrees. So that first angle is between 0 and 90. In quadrant 2, you could think of it as being 65 degrees behind 180. 180 minus 65 is 115. And then in quadrant 3, I'm going to label those quadrants for you right here. Quadrant 3, 65 degrees past 180. I'm going to add 65 to 180, that gives me 245. And then in quadrant 4, 65 degrees away from 360. And 360 minus 65 is 295. Okay. So rotation angles, reference angles, I feel like that kind of covers that first bullet, or that first key skill. Sketch angles in standard position, determine the quadrant and the reference angle. Okay. Next we move into our work with X, Y, and R. This is the hardest of the trig work. But we can remember a couple things. We have to memorize that sine theta is the ratio of y over r, and if we draw a picture, I'm just going to draw it in quadrant 1 for simplicity. The x is always the horizontal distance, y is the vertical distance, same with the horizontal axis, the vertical axis. And if you look at that reference angle, and sine, if you remember SOHCAHTOA, S-O-H, opposite over hypotenuse, it'll be y over r. So when in doubt, draw a picture. Cosine would be adjacent over hypotenuse. So the adjacent would be x, the hypotenuse would be r, so x over r. And tan would be opposite over adjacent, so y over x. The Pythagorean theorem is typically a squared plus b squared equals c squared. In terms of trig, this is always x squared plus y squared equals r squared, or the two legs of the triangle, x and y, squared and added together equal the radius, we call it squared, or the hypotenuse squared. And the casserole starts in quadrant 4, C-A-S-T. Some people like to say add sugar to coffee, start in quadrant 1. Either way, this tells you which ratios are positive. So the A stands for all ratios positive in quadrant 1, sine being positive in quadrant 2, tan being positive in quadrant 3, and cosine being positive in quadrant 4. And so it also is true if cosine is the only positive ratio, both sine and tan are negative in quadrant 4. Okay. Problems related to the Pythagorean theorem and exact values. So The point 612 lies on the terminal arm of the angle theta. Determine the exact value of sine theta, cos theta, and tan theta, and then answer as a mixed radical in simplest form with a rational denominator. Now that seems like it's making your life harder because we don't know really where to start. And so I've used the quote throughout the year, well, in trig, not throughout the year. When in doubt, find x, y, and r. If it is a trig problem and you are asked for ratios, x, y, and r. Okay? When you give us a point, I automatically have x and y. And so the first thing I'm going to do is I'm going to find r, and I'm going to find r through that Pythagorean theorem. So x squared plus y squared equals r squared. And x is 6, so 6 squared plus 12 squared equals r squared. 6 squared is 36. 12 squared is 144. If you add 144 and 36, it's 180. So we say r squared is 180. And so I have to square root that. And square root 180. Now if you try this, I'm just going to show you on your calculator. Square root 180. Not a nice number. Don't use 13.4. We go to radicals. So I can either leave it as square root 180, but I can do better than this. We can simplify. And so I'm looking for a largest possible perfect square that I could take out of that. And so I would just try a few. So 180 to me, I'm wondering if that's divisible by 36, just because I'm quite familiar with it. But I would actually start 180 divided by 4, that smallest perfect square, 2 squared, well, excluding 1. It would work, but I can do better than that. So then I would go 180 maybe divide by 3 squared, divide by 9, also going to work. Because 18 is divisible by 9, then we'll go 180 divided by 25, that wouldn't work. And then I could check 16 too. Not gonna work. And then 36 gives me 5, knowing that I can't take a perfect square out of 5, as far as I'm gonna go. So r is equal to the square root of 36 times the square root of 5, which gives me 6 root 5. So the hardest part of this work is going to be finding r. Okay, to write the ratios, sine theta is y over r, y is 12, r is 6 root 5. 12 divides by 6, which will give me 2 over root 5. And then I was told specifically to rationalize. Don't leave the root in the denominator. So multiply by root 5 over root 5, which will give me 2 root 5 over 5. Okay. Cosine theta is x over r. X is 6. R is 6 root 5. 6 divided by 6 is 1. The root 5 stays in the denominator. When I rationalize, 1 times root 5 and root 5 times root 5 gives me root 5 over 5, because square root of 5 squared is 5. And then tan theta is y over x. Y is 12. X is 6. 12 divided by 6 is 2. And so the tan ratio would be just 2. No roots and not worried about rationalizing there. Okay. So when in doubt, find x, y, and r. Pythagorean theorem, state the ratios. The questions that I give you also work backwards. We'll get down to that one a little bit later. Okay, D. Determine without technology whether or not the given trig ratios would be positive or negative, and rewrite the same trig function of a positive acute angle. Okay, so sine 335. Start with, where is that? Sine 335. Okay, 335. 0, 90, 180, 270, 335, between 270 and 360, if you want to put the comma there. So 335 about here. I had to determine if it was positive or if it is negative. Here's the cast rule. C-A-S-T, in quadrant 4, where this angle is, sine is not positive. Sine is positive in the quadrant 1 and quadrant 2. So it's actually negative. So when we rewrite it, we'll say it's negative. That would just turn the sign, but it's equivalent to the sine ratio of a positive acute angle. And that positive acute angle comes from that reference angle. So if I'm at 335, I'm thinking, how far away from 360 am I? 360 minus 335, I'm 25 degrees away from 360. So sine 25 would actually be positive, but then we're saying that this ratio for sine is negative in that quadrant. So negative sine 25 would be the equivalent trig function. Okay, tan 205. So first we do, where is 205? Okay, 0, 90, 180, 270, 205, between 180 and 270. Doesn't have to be drawn to scale, but if it is better, then you can kind of estimate a little bit better. When I think of 205 degrees, I have to also consider first which, in this quadrant, basically what is the reference angle? And when I draw that picture, when I kind of do that estimation, 90, 180, okay, 205 is past 180. I know that there is some angle here. It tells me how far past 180 I am. 180 plus 25 will give me 205. So that reference angle is 25. If I go back to the question, is it positive or negative? T fits in this quadrant. T stands for tan. That means tan is positive. So you could write a positive or you could just leave it out. And equivalent to tan of 25 degrees. Okay, so it's a positive ratio and it's equivalent to the positive of tan 25 degrees, that acute angle. Okay. Example E, if tan theta is negative 2/3 and cos theta is negative, find the exact value of sine theta. Write it again. When in doubt, like if you look at this question, you're like, I have no idea what to do. Find x, y, and r. Okay. So the first piece I'm going to break down is this piece right here. Tan theta is negative 2/3, and that negative is just out front right now. I don't know if it belongs to the 2 or the 3. And so when I look at this, I'm making the connection to y over x. So that I know that basically the absolute value of y is 2 and the absolute value of x is 3, but I'm not sure which one of those is positive or negative. So that y is going to have a numerical value of 2, x is going to have a numerical value of 3. Now I was also told that cosine is negative. Okay, so from this piece of information, tan is negative and cosine is negative. Okay, so we can start eliminating some quadrants. So if I draw the cast rule, if both of those are negative, well then we can't fit into the quadrant in which all of them are negative. If cos is negative, it can't be in quadrant 4. And if tan is negative, it can't be in quadrant 3. And so we are in quadrant 2. This is a positive y-axis and a negative x-axis, which tells me that that negative actually belongs to x, belongs to 3. So now I can say, okay, well, y is actually positive 2, x is negative 3. Okay, so y is positive 2, x is negative 3. Now, if I wanted to solve this problem, x, y, and r. So I'm going to go to that Pythagorean theorem so that we can get r, because we've got x and y. X squared plus y squared equals r squared. Negative 3 squared plus 2 squared is r squared. That's 9 plus 4 is equal to r squared, which makes 13. And then when we square root 13, 13 being prime, so no way to turn that into a mixed radical, so you say r is the square root of 13. And the last part of this problem is to say sine theta, that's what I was asked to find. Find the exact value of sine theta. Sine theta is y over r. Therefore, sine theta is 2 over root 13. It's positive, it is in quadrant 2, and a positive divided by a positive is still positive. And whenever we see that root in the denominator, we rationalize. So I've got to multiply by root 13, which will give me 2 times root 13 all over 13. Okay, that was a long question. So we've got through the majority of those key skills. I'm just going to flip back again. So we've used the Pythagorean theorem a number of times to determine x, y, and r given a point or a ratio. We've been stating cosine, sine, and tan as exact values. And, well, we haven't quite got to solving for the angles. I believe that's what's going to come next. So we tackled 2 bullets off those key skills on this page. Okay. When solving for the angle, you need to use the second function button. Okay. What I mean by that is in solving for the angle, you should be hitting second sine, which will give you sine -1 or sine inverse, second cos or second tan. Because you don't need the ratio, you need the angle. It helps to be familiar with the unit circle. However, if you're not familiar with the unit circle, you're going to be just fine. You can use your calculator to solve the problem, or if you would like to use the unit circle, we can use the hand rule as well. So in solving for the angle, it says determine the exact measure of theta, where theta is between 0 and 360 degrees. Where would cos theta be negative root 3 over 2? I'm going to show you both ways. First, I draw a picture. I always draw a picture. Cos theta is negative root 3 over 2. What I take from that is cos theta is negative, which tells me I am either in quadrant 2, where cos is negative, or in quadrant 3, where cos is negative, because cos is positive in these two. And so I need to solve for that reference angle. So I know this on the unit circle. I'm going to show you on your hand what to do. So this would be 0, 30, 45, 60, and 90 degree reference angle. Cosine occurs above. So if I need root 3 over 2, I hold down 3 fingers. Hold down this finger so that you have 3 fingers above. Okay, that tells me the reference angle is 30. And so I'm going to show you as well on the calculator, if you didn't know that, cos inverse of root 3 over 2. Oops, close the root 3. Reference angle 30 degrees. Okay, so 30 degrees here, 30 degrees here.